Welcome to this video where I'm going to talk about the binomial probability, and I'm going to link it to expected value and variance. Well, expected value, what's that? Well, in this context it's a measure of central tendency. Or the most likely occurrence. Whereas we can also calculate for the binomial probability the variance, VAR. And the variance in this case is a measure of spread or dispersion. And if we have a variable x which is binomially distributed, then the expected value E of x is simply the number of trials times by the probability n times by p. And the variance VAR of x is number of trials times the probability times by the probability of failure, which is 1 minus p. So what would that look like for this example over here? So I toss a fair dice 6 times. What's the expected number of times I would get a 6? Well, they're asking us for the expected value, or the most likely value, if you like. That would be the number of trials, which would be 6, times by the probability of getting a 6, which is a sixth. 6 times a sixth is just 1, and which makes sense, doesn't it? What's the spread of the data? Well, that would be the variance. That would be the number of trials times by probability of success times by the probability of failure, which is 1 minus a sixth, which is 5/6. So that would be 6 times a sixth was just 1. 1 times 5/6 is just 5/6. So that tells us something to do with how spread out the data is.